Imagine a robot no bigger than a paperclip, one that not only flies like a bumblebee, but could someday help humanity farm on Mars. Sounds like science fiction, right? But MIT engineers have turned this bold vision into reality. And this is where it gets really fascinating. This minuscule machine might change everything we know about robotics and agriculture here and on other worlds. Developed by the innovative minds at Kevin Chen's Soft and Micro Robotics Lab at MIT. This tiny robot weighs less than a gram, lighter than a paperclip. Despite its size, it flaps its wings a stunning 400 times per second, mirroring the motion of a real bee. These wings aren't ordinary. They're powered by 4 soft, artificial muscles called actuators, enabling the robot to hover midair, flip with agility, and dart in any direction. But here's what really sets it apart. The robot can also hop. With a springy leg inspired by the acrobatic leaps of fleas and grasshoppers, the bot can leap 20 centimeters, 4 times its own height, at a brisk pace of 30 centimeters per second. This clever hopping isn't just for show. It slashes energy use by 60% compared to similar-sized flying robots. Even more impressive, it can ferry loads up to 10 times its own weight, meaning it could haul sensors, microcircuits, or tiny cameras wherever they're needed. How does it work? The secret is deceptively simple. A compression spring, much like the one in your click-top pen. As the robot lands, the spring stores the energy from the fall and releases it as the next leap, propelling the robot upward. The wings keep things stable, ensuring each jump lands at just the right angle for the next takeoff. This hopping system has proven reliable on a variety of surfaces, from soft grass to slippery ice, wet glass, rough soil, and even the unstable wing of a moving drone, hinting at possibilities for robots working together in dynamic environments. But here's where debate might start. While flying robots must constantly expend energy to stay airborne, hopping bots are far more efficient, recycling energy with every leap, just like a rubber ball bouncing repeatedly. In theory, says Project PhD student Yixuan Xiao, the robot could hop forever without losing energy. In practice, however, there is a bit of energy lost on each jump, but the robot's wings can easily compensate, so it keeps going relentlessly. If you're skeptical about the durability of such a tiny device, that's understandable. But tests have shown the robot can crash land hundreds of times without breaking, thanks to those flexible actuators. Of course, jumping alone isn't enough and master challenging terrains. To stay on course, the robot leverages both a motion tracking system and an adaptive control algorithm. As it soars through the air, it constantly analyzes its trajectory, tweaking wing movements to ensure it lands in just the right spot, even on slanted or changing surfaces, or when jumping between very different materials like glass and grass. That means it can tackle complex, unpredictable tasks without missing a beat. The practical uses for this technology are both exciting and in some cases controversial. On Earth, these robots could pollinate crops in indoor farms where real bees struggle under artificial lighting conditions. Jump to Mars and suddenly, these tiny machines could become the backbone of Martian farming, doing the job no living pollinator can. Their small size and incredible payload capacity also make them candidates for critical missions. Think environmental monitoring or searching for survivors in collapsed buildings where bigger robots can't reach. Their nimbleness, shown in acrobatics like mid-air flips, suggests teams of these robots could even collaborate on demanding, coordinated tasks. But what do you think? Do tiny, almost insect-like robots represent the future of farming and exploration? Or does the idea of robotic pollinators give you pause? Do the potential benefits outweigh the concerns about deploying such technology on Mars or even here on Earth? Share your thoughts. Would you trust robots over bees to secure our food future?